Hello, dear learner. Welcome to my channel. This is the Gen Z analyst, and in this particular video, we are coming to continue our discussion on investment appraisal techniques, and we are specifically looking at internal rate of return, or what you call IRR. So, we have previously covered other investment appraisal techniques such as the payback period as well as the discounted payback period. We looked at accounting rate of return or ARR. We looked at simple interest and compound interest and its associated annuities, future value of annuities and perpetuities. We also looked at net present value fundamentals, which I said we are going to continue looking at issues such as inflation and taxation and how they affect NPV calculations. So in this particular video, which happens to be our fourth video in the series, we are coming to look at internal rate of return. So what is the internal rate of return? This is a discounted cash flow technique. All right, is the second discounted cash flow technique in addition to NPV, and its calculation is very similar to NPV. I mean, if you know NPV calculation, internal rate of return shouldn't be a problem for you. So internal rate of return is a very popular discounted cash flow technique, and when we talk about IRR, it is the discount rate at which the present value of a project's cash flows is zero. Okay, and it is also called the break-even rate of return. It is the discount rate which, when used to discount the cash flows of a project to their present values, results in an NPV of zero. That is why you are calling it the break-even rate of return. Alright, so that is a brief description or definition of the IRR. Now, it represents the highest acceptable finance cost of investment to investors. The highest acceptable finance cost, in that if the finance cost of a particular investment project is more than the IRR, such an investment will be typically rejected. All right. Okay. So let us look at the decision rule for IRR. The IRR decision rule is that if you calculate your IRR and it is greater than your cost of capital, accept the project. If the IRR is less than the cost of the project, then that project should be rejected. So that is the decision rule for IRR. All right. Okay. So let's continue. Now we are coming to look at the IRR of perpetuity. Now, as we have already looked at perpetuity, it is regular cash flows that occur forever or indefinitely or infinitely. So regular amount of cash flows that you receive forever, that is perpetuity. And when it comes to the IRR determination of a perpetuity, the following formula, as you are seeing here, is typically used. All right, so we will take the annual regular cash flows and divide it by the initial investment and multiply by 100. That is the IRR of a perpetuity. All right, so the initial cash flows coming from the investment, which is the perpetuity, divided by, so we will pick the annual cash flows, which are the perpetuities, divided by the initial investment and multiply by 100. So we have an example here to clarify the or to help us understand the formula for us. So Eze makes an investment of 20,000 that earns annual cash flows of $3,000 in perpetuity. what is the internal rate of return. Right, so the solution is very simple. IRR of a perpetuity is what? The annual cash flows divided by the initial investment multiplied by 100. So the annual cash flows from our question is $3,000. We divide that by the initial investment of 20,000 and multiply the result by 100, and that will give us 15%. So that is the IRR. So in case the company's acceptable cost of capital is 12%, then we are saying that this particular investment project can be accepted. All right, it can be accepted. But where, let's say, the cost of capital is 18% and you're having 15%, then the investment should be rejected per the decision rule. Okay, per the decision rule. All right, so that is it for perpetuity. I hope you get it. It is very simple. It is very, very simple. Now, this formula is not given in the exams, so you should remember it. And it's very simple. Just take the annual cash flows from the investment, that is the perpetuity, and divide it by the initial investment and multiply everything by 100. That will give you the IRR of a perpetuity. Now, closely related to perpetuity is annuity. Annuity is the same as perpetuity. The only difference is that annuities have a particular year end. So you take your annual regular cash flows up to a particular point in time. That is annuities. All right. So let's say for the next 5 years, you'll be receiving 2,000 each every year. So that is what you call annuity. Whilst perpetuity, you receive that amount forever. So they are saying that to give an NPV of 0, the present value of the cash flows must equal the initial cash outflow. This means that annual cash flow and cash inflow multiplied by the annuity factor, which we have previously looked at, is equal to the cash outflow. This is the formula we use when you are calculating the cash flow from annuities. Cash flows in the form of annuities. Now, this equation can be rearranged to solve for the annuity factor. So if I want to find the annuity factor for calculating IRR of an annuity, this is the formula I'm going to use. So annuity factor can be calculated as the cash outflows from the project divided by the annual cash inflows. This formula too should be learned and remembered in the exams. All right. So for perpetuity, simply pick the cash outflows, cash inflows, and divide it by the initial investment. For annuity, and this annuity is you are calculating what? The IRR. Remember, IRR is a percentage value. All right, it's a percentage value. So annuity factor is calculated by taking the cash outflows and divided by the annual cash inflows. Once we know the annuity factor, the corresponding discount rate can be determined from the annuity table, which is usually given in your exams. So let's go to Excel and see some of the issues that we can see when it comes to calculating the IRR of annuities. All right. So here we are in Excel. So this is an example on IRR of annuities. An investment of $6,340 today is expected to yield a net annual cash inflows of $22,000 for the next 4 years. So we are to calculate the internal rate of return of the investment. All right. So let's have solution here. Now, since this is an annuity, we are going to use the usual annuity calculation format. All right. So I'm going to have here time. I'm going to have here details. We have looked at it in our previous videos on NPV calculation. So then we have the cash flows, which is actually a dollar amount. All right. Then we'll have our discount factor / annuity factor. And we are going to have our present values. Our present value, which is also a dollar amount. All right, so this is the format we usually use. Let me nicely. All right. So what is the time here? We have been told that um, the investment is supposed to yield annual net cash inflows of 2,000 for the next 4 years. And then we have an initial investment of 6,340. So we know that initially we are going to have times 0. And then since this is an annuity, we are going to have what from time 1 to 4. And since this is going to be, so it has converted the 1 minus 4 to, so I'm going to have time 1 to 4. All right, and then I can align this to the right. Okay, so our initial investment according to the question is 6340. I'm going to select everything here. Format is as an accounting figure with 0 decimal places. All right, then our annuity is, so we have annuity here. Our annuity is going to be, okay, so this amount is supposed to be here, and this is supposed to be initial investment, and then our annuity is $2,000, 0 decimal places. Then for the initial investment, which is supposed to be negative, for the discount factor for the initial investment is always 1.000. So I'm going to increase this to 3 decimal places. And then our present value is the cash flow multiplied by the discount factor of that. Then now we are going to calculate for the annuity. And the annuity, the formula has been given to us. Okay, so the annuity factor, which is AF, so we'll have workings. Now, annuity factor AF, as we have studied in the slide, is going to be equal to our initial investment of 6340, or I can just do equals, flip the sign because this has been made negative, so I'll put negative before the sign and divide it by my annuity. Okay, and that is giving me 3.17. So quickly, that is my annuity factor. So I can come here and write or link that particular solution here, 3.17. And so with my annuity found, I can now find the present value of my annuity, which is the annuity cash flow multiplied by the discount annuity factor of 3.17. So actually, you're supposed to edit this to 3 decimal places. All right, so as that is what we have for our annuity, and as we know, IRR is that discount rate which, when applied to our cash flows, is going to give us an NPV of 0. So let me insert. So our NPV or the net present value will be equal to 0, which is the addition of these two figures here. All right, so it's equal to 0 there. So that is how we calculate for the IRR given annuities. Now, the IRR is still not found. Okay, you can agree with me that we have not found our IRR because this is annuity factor, this is NPV. So where is the IRR? So that is where you make use of your annuity factor table. All right, the annuity factor table to find your IRR. So how do you do that? On the annuity factor table, you are going to locate an annuity at 4 years. So this project is supposed to last for 4 years, and we have already calculated our annuity. So you look at 4 years and this number and trace to the particular discount factor that is giving us the 3.17 here. And from the annuity table, if you do that correctly, you should be getting an IRR equal to 10%. All right. So when you trace that on the annuity table, you are going to have an IRR of 10% approximately. So that is our IRR. Okay, that is how you do it. All right. So with this done, let us move to other things with regards to IRR calculations. Okay, so now we are looking at estimating the IRR of an investment using the linear interpolation formula. So now that we have touched on the IRR of perpetuities and annuities, what if the cash flows are neither perpetuities or annuities? Then, if that happens, an interpolation formula can be used to estimate the IRR. Now, the steps to be followed are as follows. So, first, you calculate the NPV of the project at any selected cost of capital. Okay, so you randomly picked a cost of capital and calculate your NPV using that particular cost of capital. Now, step 2 says that if NPV is positive, recalculate the NPV at a higher cost of capital. That is to get an NPV closer to 0. All right, you need to get this very clearly. Then, step 3, which is actually a variant of step 2, it is only one of step 2 and 3 that happens. The both cannot happen. Okay, now step 3 is saying that if you calculate your NPV and it's negative, as in step 1, recalculate it at a lower discount rate again to get an NPV closer to 0. Now, at any point in time, your NPV should be closer to 0 for you to get a more accurate IRR calculation. All right. Now, the following formula can be used to estimate the IRR after you have gotten your positive NPV and your negative NPV. So this is the linear interpolation formula that is used to calculate IRR. Now, the formula might use complex at first sight, but it's very simple. So to calculate your IRR after determining your positive NPV and negative NPV, you have the rate. You have 8% plus bracket open NPV calculated using the 8% divided by the NPV of 8% as we have as the numerator minus NPV calculated using another discount rate called discount rate B. And then we close the bracket and multiply the result by the difference between the two discount rates. Now, this is the formula. So what's the interpretation of A? A is a discount rate that gives a positive NPV. B is the discount rate that gives a negative NPV. So this is supposed to be negative. So this is negative NPV. All right. So the B here is the discount rate that gives a negative NPV, not positive. NPV of A is referring to the NPV we got using 8%. Okay, which is usually the positive NPV. And then the NPVB, which you have in the formula, is the NPV using B%, which is usually the negative NPV. Now, this formula is not provided in the exams and so should be memorized. All right, so that is it for calculating IRR, where the cash flows are neither perpetuities or annuities. So let's head back into Excel and see some worked examples. All right, so here we are in Excel. We are looking at example 2 using the linear interpolation formula. So this is our example. A company is considering an investment in a project for which the following cash flows have been estimated. So you have end of year 1, 20,000, year 2, 30,000, year 3, 30,000, year 4, 17,000. So these are the cash flows from the proposed project. Now the proposed project requires an initial investment of $80,000 in capital assets. The assets would be expected to be sold at the end of the project for $25,000. The shareholders require a minimum expected rate of return of 12% on investments of this type. So this is the minimum expected rate of return for investments of this type. So we are going to use this as a benchmark for determining the acceptability of the project based on the IRR we calculated. So you are required to, one, calculate the IRR of the project, which is using the linear interpolation method, and two, calculate the IRR using the IRR Excel function. Alright, so we are going to use the two methods to calculate it. And now you should know that these two methods give very different results. Alright, they don't give similar results. So take note of that. Alright, so quickly let's go and do our solution. So we have solution here. Now, as I have been saying, when you read your question, you need to read it very carefully to know the format of NPV calculation. Now, IRR determination is all about calculating NPV. Okay, it's all about calculating NPV. Two NPVs, one should be positive, one should be negative, and we use the linear interpolation or the linear interpolation formula to determine our IRR. So it's all about calculating NPV. So, as I said before, or in my previous videos under NPV, the question or the scenario should be read carefully to know which format of NPV calculation you can conveniently use. Alright, so when you look at this, the cash flows are of the same type. The cash inflows from the project are of the same source and of the same type. So we can use the annuity-based format to calculate our NPVs. Alright, so that is what we are coming to use. Where you are having cash flows from different sources, different sources, then you can use the cash flows method of presentation. Okay, so that's just a tip I'm giving you. So let's go to our solution. Now we know that this is going to be what, as we have before, the time, we have details, we have cash flow, which should be this, we have discount factor, we are going to have present values, and then because we are going to calculate two NPVs, we are going to repeat the discount factor as well as the present values again. So what I'm going to do, I'm going to have this and repeat it twice. All right, and repeat that twice. So let me increase this a little, and also format these parts. Format this as an accounting figure with 0 decimal places. Format this one too as an accounting figure with 0 decimal places. Alright, so with that done, we can now start with our calculations. So this is what you are going to have. You are going to have times 0, which is small t 0, and let me align this to the right. We are going to have time 1, so let me also align that, and then with these two I can use the fill down to fill the rest. So we know that this investment is supposed to last for 4 years with so let me delete the last time there. Then with our details, we'll have investment, initial investment. Then for time 1, we are going to have cash inflow, and that is going to be repeated for the rest of the 4 years. And then we are going to have another time 4, which is the scrap value of the asset at the end of the project. So we have scrap value, which is also at year 4. Alright, so that is what we do. This is not new. We have covered this in our previous videos. That is why I am not explaining how I'm treating all those things. All right. Now, what are the cash flows? We have all of these, so I can just link them there. So I can just link this. Sorry. So I can just link this. Let me cut this and paste here and copy it down using Ctrl D. Then for our scrap value from the question, we've been told that the asset will be expected to be sold at the end of the project, which is for year 4 for 25,000. So I'll have my 25,000 right there. Okay, so these are the cash flows. Then the initial investment is 80,000, which is going to be a cash outflow. So we have that with 0 decimal places. All right, so we have our everything set up for us. So now we can randomly pick any discount rate and find our discount factors. So we can randomly pick any discount factor. So what are we going to pick? Since the minimum expected return rate here is 12%, I can use that as a guide so that I don't pick anything random, too random. So I can pick 15% as my first rate. So discount factor at 15%, and then the second one I can pick at 20%. Remember, there is no right or wrong discount rate here. Just make sure that you pick one that correctly predicts your NPV. That now the IRR is a relative measure and it is highly subjective. Okay, it is just an estimate, so you don't have any accurate IRR calculation. Okay, so we have the 15%. Now I'm going to format this as a decimal. So I'm going to have, okay, so let me just leave that for now. So we are going to have 1.000 for the first one. The same thing applies here, 1.000. So what do I have? I'm going to increase it to 3 decimal places. Increase this to 3 decimal places. Okay, now we know that to calculate our discount factors is going to be 1 divided by bracket open 1 plus our discount factor of 0.15 bracket close raised to the power the time, which is time 1. Okay, so I'll have 1 there and close my parentheses. So that will give me 0.870. I'm going to copy and drag this down. Then all I have to be doing is to be changing the times there. So this is year 2, this should be year 3, this should be year 4, this should be year 5. Sorry, year 4 again. All right. And then I can copy one of this and paste here. And all I have to do is to change the discount factor to 0.20. Okay, so having that, I can copy again down, fill down, and change the times 2, 3, 4, and then 4 again. All right, so that is what we have. Now that we have gotten our cash flows and our discount factors, we can find the present values. So what is going to be our present values? We are going to have the cash flows multiplied by our discount factors. So with this, I can copy this and paste here and paste, and that is giving me my discount factors there. All right, and coming here, we can do the same thing. It's going to be the cash flow multiplied by the discount factor. I'll enter, copy this formula, and paste down. Sorry. So I'm going to copy this and paste down here. All right, so we have everything set up for us nicely. So let's go ahead and calculate our NPVs. So we have NPV. So what is our NPV for the discount rate at 15%? So I'm going to sum everything here together using alt equals, which is the shortcut for auto sum. That is giving me 3815 or $3,815. And then let's look at the second one, alt equals, and that's giving me negative 4,884. All right. So with the two present values or net present values obtained, positive and negative, we can use the linear interpolation formula to calculate the result. So I have the formula here. Let me cut that. Come to our calculations and paste here. So what do we have? I have my linear interpolation. Let me extend that. So let me say using linear interpolation, IRR is equal to A% plus this. So all we have to do is to determine the values here. So what is our 8%? 8% is the discount factor that is giving us the positive NPV, and that is what, 15. So I can just put 15 there. Then I'll open my parentheses or the brackets, and the NPV of A is what, this. I will divide that by another bracket open, the NPV of A again, and I'm going to deduct or minus this. And remember, this is going to give us what, a positive sign here, because it's negative negative. So at the end of the day, the effect is going to be a positive number. All right. So I'm going to close that particular parenthesis there, and close also this one, and multiply the result by the difference between the two discount rates. Okay, so we have 20 and 15. So actually I can just write 5 there, because the difference between 15 and 20 is 5. So it's 20 minus 15. That was giving us 5. So I can just put that there. And this is giving me 17.192. And I'm going to reduce the discount rate to, since this is an estimation, we usually reduce the decimal places to only one decimal place. So this is 17.2%. Sorry. So let me convert it to a number again. So that is 17.19%. All right, that is our IRR. I hope you get it. So this is using the linear interpolation method. Okay, so sorry. So I can copy this and paste here. Now the second requirement is we should use what, the Excel function, IRR function. So to use the Excel IRR function, this is what is going to happen. We are only going to have these parts. Okay, so I'm going to copy this and paste here. I'm going to link to the various items and drag downwards, fill downwards to here. All right, so we have our IRR, and that will be equal to IRR, that is the function. Now, for those who are writing your ACCA, the IRR function is in the CBE platform. So you can use the IRR function on the your CBE computer-based software to perform your IRR calculation, so that you don't have to go through all of this unless the requirement says so. All right, so you can just do that. And so we are seeing that the first one is values. So what are our values? So I'm going to select all the values here, and this one we are going to include the initial investment as well. So we just enter, and then let me increase this. Convert it to percentage. So that is giving us 16%. This is giving us 16%. That is our IRR. So as simple as that. Using the IRR function is very simple. Now, since the computer-based software that is being used in the exam has the IRR function, you should immediately know that the issue is going to be about identifying the relevant cash flows. Identifying your relevant cash flows. So you should be very careful when you're reading a scenario in the exams, because the marks are not going to be based on your calculation per se, because the calculation is quite simple, all right, especially using the IR function and then the NPV function in Excel. So what you have to know is identifying the relevant cash flows to be used in your calculation. That is where the main deal comes in. All right. Okay, so having said that, let's talk a bit about the IRR function. So the IRR function has two arguments. The first one is required, as I said, when you are looking at, when you are looking at any Excel function, we have required arguments as well as optional arguments. Okay, now the optional arguments are put in the square bracket, as you can see here, whilst the required arguments are usually not put in square brackets. So when you look at the IRR function, we have values, and then we have what a bracket guess. Okay, so the guess is usually a bit of complication. You have to be guessing some using some discount rates. Okay, so that is usually not advisable to use. So what we usually do is just select all your cash flows, close your parentheses, and hit enter, because you have fulfilled the only requirement, which is the values. All right, so that is something I want to touch on before we move on. All right, so having done this, I think we are done. So let's go back to PowerPoint and see what other information we have regarding discounted cash flow techniques. All right, so that is it for the linear interpolation formula for calculating IRR. Now let's look at the relative advantages and disadvantages of NPV and IRR. So advantages of NPV, we have one, it considers what the time value of money. Okay, that's an advantage. It is an absolute measure of value to shareholders, as we have previously discussed, because NPV gives you the real value that is being added to shareholder wealth. Okay, so that is an advantage there as well. Now, NPV calculations are based on cash flows and not profits, as we have in other investment appraisal techniques such as the accounting rate of return. Okay, and then it also considers the whole life of the project, which is actually an advantage compared to the payback method, which does not consider the entire cash flows of the project. Okay, so those are the advantages of the NPV. What are some of the disadvantages of using NPV as an investment appraisal technique? It is relatively complex. Okay, it is relatively complex, especially when we are dealing with inflation using the Fisher's model and talking about taxation issues, capital allowance, and all that. It can be a bit complex, and then it also requires the knowledge about the cost of capital, because you need an acceptable cost of capital to be able to get what an acceptable NPV. Okay, it's not every NPV that is reliable. So for the NPV to be correctly calculated, then you should be able to determine your cost of capital correctly, which is usually the weighted average cost of capital for the company. Then it is also difficult to understand by non-finance managers. So those who do not have finance background find it difficult to understand the calculations of NPV and its interpretation. All right. Now let's come to advantages of IRR. It also considers the time value of money because it's a discounted cash flow technique. It is relatively easy to understand. All right, because as soon as you understand NPV, you should be able to understand IRR as well. It's based on cash flows, as is the case for NPV as well. And it also considers the entire life of a project. Okay, it's considered the entire life of the project. Now, what are the disadvantages of IRR? IRR actually has a number of serious disadvantages. The first one is that it's not an absolute measure, it is a relative measure. And that makes it difficult for us to know the value it is creating for shareholders. Okay, it doesn't or it takes no account of the relative size of a project. It therefore cannot be used or relied upon when making investment choices. Okay, because you don't know the impact it is having on the project in the first place. So it's not an absolute measure. That's a disadvantage. It requires knowledge about cost of capital, just as we have with NPV. Interpolation provides an estimate. Okay, interpolation provides an estimate because, as you can see, we are just randomly picking the discount rates and then using those to calculate our IRR. So it provides just an estimate and not an accurate figure. It is fairly complicated to calculate. As you can see, I have to calculate two NPVs for us to use the linear interpolation to be able to derive that. So that is also a disadvantage of IRR. All right. So overall, NPV is the most superior when it comes to discounted cash flow techniques. But that is not to say that IRR is not used in practice. Both methods are used in practice, as managers often um, um, have reasons for using each of the investment appraisal techniques. And typically, they use each of the investment appraisal techniques and complement the result of one with the result of another. All right, so that is what they do. So having said that, we have come to the end of IRR. In our next video, we are coming to look at relevant cash flows and also consider the issue of taxation and inflation when calculating NPV. Alright, so thank you very much for your time in this particular video. If you haven't subscribed to the channel, please subscribe to the channel. Also consider liking the video and don't forget to leave comments in the comment section so I can look at them and follow up on any issues that you might have. Alright, so until then, I will see you in my next video.